Hi, I'm here today with frequent CMG contributor Jamie Baker. Jamie joins me from the UK and is a product management director at SyncSort. Welcome, Jamie.
Oh, hello there, Amanda. How are you?
I'm doing great, Jamie. Thanks for asking. Now, just to get us started, CMG was founded more than 40 years ago as an organization to support capacity management professionals. And today, I wanted to talk to you a little bit about that. With capacity on demand via elastic or utility computing, some people are saying capacity management isn't really required anymore. I'd love to get your take on this and how has capacity management evolved?
Yeah, that's a really good question, and it has evolved over time. I mean, if you think back to, like you say, CMG's been going for a long time, 40 years, and back then, of course, we were just dealing with physical systems, specifically what we call legacy systems today. So things like the mainframes, which are still very important, but they're physical systems. And what's happened over time is we've moved into a more elastic, or sometimes known as utility computing model. So things like virtualization and cloud, and therefore capacity on demand is available for organizations to tap into. You've got your big cloud providers that allow us to spin up virtual machines or spin them down whenever we like, and they charge us accordingly, and hence why it's called a utility computing model. So in that case, capacity management has changed in the way we look at that, but it's still as important as it ever was. And the reason for that is there's a focus now shifting in the utility computing world of not so much focusing on how many resources we have and what should we plan for and tying it to a budget, every budgetary process every year. It's a much more dynamic process. It's a much more frequent recurrence in terms of our planning. But the focus is shifting from resources to cost, because just like you get electricity and you pay for what you use, you're going to pay for what you use in the cloud. So therefore, how do we plan effectively of what we need in the cloud? In terms of just taking like for like, if you're switching from an on-prem to a cloud, and also what's that going to cost us? And people spin things up and forget about them very easily. So again, that's going to accrue costs as we move over time. So we need a process of governance where we can say, what do we need? What's our optimum level of resourcing? What's it going to cost us? Keep a control over these things as they spun up and spun down, and make sure that, capacity is at the forefront of being able to control those costs over time.
And it's interesting, every company is in a different place in their infrastructure journey, but they all are having to make these considerations on how they're managing those systems. Where do you think most companies fall in their infrastructure management maturity?
Yeah, I mean, I've done over a number of years. Before I became product management, I was consulting in capacity for many years, and I've done some what we call gap analysis on maturities of the process, and speaking to a number of organisations around that. And we also have surveys that you can get results on. And where I would see them fall into this infrastructure maturity is somewhere between what we call level 2 and level 3. So level 2 really is what we call repeatable. And repeatable really is more kind of, you're still firefighting, okay? So you're still not as proactive as you should be in terms of your capacity management. There is some automation being built in there. You are starting to get what we call a basic level of capacity infrastructure reporting in place. But it's not quite where it should be in terms of engaging with other stakeholders in the organization. But then some other organizations have taken that level further and are engaging with things like business and service owners, putting in capacity portals and reporting, and starting to mature as they engage with these stakeholders, the levels of reporting that they need and the forecasting that they need to make these decisions. So absolutely, between levels 2 and 3, I would say it's pretty common throughout the customers that we've spoken to.
And with the move for more companies to build in digital transformation efforts and continually improve their systems in the way that they're servicing their internal and external customers. Do you see that drive for digital transformation impacting IT infrastructure and capacity management?
Absolutely. Yeah, absolutely. As we've just been talking about, the evolution of how technology is being used within organizations now, and the leveraging of the elastic or the utility computing, the digital transformation that you're talking about. It's very easy, as I said before, for organizations to start tapping into this utility computing, spinning stacks of VMs up very quickly and then spinning them back down again, so that capacity on demand. Because it's a faster market approach, okay, the whole DevOps faster market. The issue I think a lot of organizations have, and where they're trying to play catch up, is the development of the applications that they're running that support their critical services. And what I mean by that is that a lot of applications can't scale that way. They're not written to be elastic in the way that you can spin things up and spin things down very quickly. The new applications are written that way, but there's still a lot of legacy applications that support their critical services that still need to be, looked at, and whether the direction of going to elastic or cloud is still need to be taken by those organizations.
Is there an application of AI or machine learning that can help with those legacy systems and their inability to scale?
Yeah, absolutely. We for a number of years now, we've always looked at dealing with legacy systems using machine learning in terms of a couple of things to mention. One is obviously your typical trending, and you've got this linear trend extrapolation that people tend to use to kind of do what we call exception reporting or exception forecasting, which means you take your data over time, you look for your peaks, and you put a trend line on that. And then if it breaches a threshold in time, you alert on that, and you look at that and you make some decisions. Where we need to be a bit more around legacy systems and machine learning is how we can do what we call queuing theory and analytical modeling. So what is it we're trying to do? What workloads are growing? How is that going to impact the response times of these systems? And then the machine learning, the algorithms that are used to predict when the knee in the curve is going to occur in the future. How far have we got? What do we need to do in terms of changes to the configuration of systems, or whether there's upgrades needed and what upgrades are required, and so on. So yeah, absolutely. And if I quickly just move that forward to the digital transformation and the elastic and the utility, is the non-linear trending capabilities. There's some really good statistical analysis now that allows us to do non-linear forecasting and to see, the impact of how, because machines, the elasticity of the machines change so fast and configurations can change very quickly, is the non-linear trending is what really gives us that kind of forecasting focus of how things are going to impact in the future.
And with the speed of all of this change, organizations find themselves, as you mentioned, with a lot of different instances, and technology is spread among all different areas of an organization. So I'm kind of wondering, how do you try to centralize and mature your capacity process across that kind of organization that's very siloed into many domains and technologies?
Yeah, again, that's a really interesting question, because a lot of challenges for organizations in terms of capacity management is a lot of it is siloed. Okay, so you get a lot of different domains doing their own thing. Okay, so they look after their own area, and to try and mature a capacity process, really, the benefit of doing that is to get the buy-in from the economic buyers and whether you call them evangelists or users, the day-to-day users of tool sets, or actually trying to produce what the organization requires from a capacity and performance process. So the centralization needs to be brought in from the top, and we centralize what we call, ideally what the process is after is a capacity management information system. Now that is a solution, or it could be a single tool set or a number of things stitched together, but essentially you bring yourself out of the silos and you layer the process across the organization. Now that could mean that domains, let's take, for example, if you're in the mainframe space, mainframe don't talk to distributed. Okay, fine, they're siloed. But what you can provide them with a capacity management information system that can be used in a siloed environment and can be used, across the organization centrally. And that's the real challenge here, is being able to provide that single centralized solution with an organization that can be distributed and siloed, but also providing the return on investment of why that maturity of that process and the tool sets that support that can provide back to the organization.
And would you have any recommendations for how someone can get that greater look of their infrastructure in order to, support business level decisions, identify bottlenecks, and really, have a better seamless integration of their service and component level systems?
Yeah, I mean, like I said before, we got data everywhere, right? So we got many tool sets within the organization using some kind of data, and that data that they collate from the applications that they're using is being used to make decisions. Okay, so what we're trying to provide to an organization here is how to provide them with the data and the intelligence that they can make accurate business decisions. If we split the capacity process down into their sub-processes, business, service, and component. So what we're looking to do is correlate the component level information together with the service level information. And that could be taken from application performance tools. Okay, so specifically transactional information, response time information, calls to a database, calls to a web server. We're getting that information, that data, and we can combine that with underlying component infrastructure information, like how much CPU have I used? What's my capacity headroom? What IOs, are they being slowed down? Is the response time different? How does that correlate to the service level information that we're bringing in? If we forecast it forward, is there a change? What if we what if we put in, what if scenarios? How's that going to impact on these, on the underlying component and in relation to the service level information? And that provides us with this end-to-end view of response time information, where things are slowing down, pinpointing bottlenecks before they occur, and again, providing that accurate information back to the organization so that they can make those business decisions.
And really, that's what it's all about, is being able to make the right decisions to move your business forward.
Absolutely right.
Well, Jamie, thank you so much for joining me today.
It's a pleasure. Thanks very much for inviting me.